When you combine the gravitational potential energy and the elastic potential energy and the kinetic energy into one energy, that energy would be called a mechanical energy. As what you can see here of what is called as Newton's game, this game is mainly related to the second law of motion for Newton. The ball here is going from one position to the other one. So you can see each ball here is transitioning, especially the balls on the side, from potential energy into kinetic energy into gravitational potential energy all at once, and dynamic energy as well, which can be described as a mechanical energy in this case. So when the work is done on the system, there may be changes in the potential and the kinetic energies of that system. This relationship can be expressed as the work energy theorem. What is work energy theorem? It's basically an equation describing the relation between the energy and the work, as the name explains. So Newton's law of motion discussed that the non-zero net force causes, let's say, an airplane to accelerate along the runway. Since the change in kinetic energy must involve a change in speed, kinetic energy changes are always the result of acceleration, which in turn caused by a non-zero net force. In terms of work and energy, this means that changes in the kinetic energy delta EK are always the result of the work done by a non-zero net force W net. And we know that W net is the F by the distance, which can be described as the F net by cosine theta delta D, and F net can be expressed as the mass by acceleration by cosine theta delta D. In all the cases, work done by a non-zero net force result in change in kinetic energy, but the applied forces on an object may cause changes in the potential energy, kinetic energy, and both. For a jet plane, when it is in the air, the thrust produced by its engine must increase the speed delta EK, cause it to gain altitude, in this case gaining potential energy, while it is gaining kinetic energy in the same time. Now let's study the net forces effect on energy. Let's assume there is a motor pulling a block up a frictionless inclined plane or surface at a constant speed and exerting a force that causes the change in gravitational potential energy but not the kinetic energy in this case. The constant speed indicates that the applied force F applied is exactly balanced by the F gravitation parallel. That's the parallel component of F gravitation, as you remember. So the zero net force here is produced because the applied force equals the gravitational parallel force. So the F net is zero, and we can see that the work energy theorem states that the work done on the system is equal to the sum of the changes in the potential and kinetic energies of that system. When you have the net forces or the kinetic energies equal the potential energies, in this case you have a work energy balance. We can annotate the work energy theorem as W equals delta E and W equals delta EK plus delta EP, because delta E is split into the kinetic energy and the potential energy, and this is called the work energy theorem that we will use to solve many problems on this topic. Now, if the F net is larger than zero or the F applied bigger than the F gravitational parallel, in this case, the box will be able to gain a speed uphill and be able to move from his position. So in this case, there is no work energy balance. So this is why we got the box moving. Delta EP, it is important to mention that it could be gravitational potential energy, elastic potential energy, or the sum of the gravitational and elastic potential energies. Let's take an example. A block is moved up in a frictionless inclined plane by a force parallel to the plane. That's the force applied. At the foot of the incline, down below, the block is moving at 1 meters per second. It's moving with a speed V1 equal 1 meters per second. At the top of the incline, 0.85 meters above the lower end, so the height is 0.85 meters. The block is moving at 4 meters per second, so V2 is 4 meters per second. The block has a mass of 1.2 kilograms. What is the work done on the block as it moves up the incline? We start with the givens. We have the mass, V1, V2, delta H, and gravitational acceleration, of course. What he needs? He needs W. W, we know, equals delta EK plus delta EP. But delta EK means EK2 at position 2 minus EK1, or the kinetic energy at position 1, plus EP equals mg delta H. EK2 means 1 over 2 mass by velocity 2 squared minus 1 over 2 mass by velocity 1 squared. We do the calculation between parentheses. When we're done, we put it down below, plus the mass by gravitation by the delta height. We do the calculation needed. We have the mass here as 1.2, keep it as kilogram. We have G as 9.81. We have delta H as 0.85 minus 0, which means 0.85. The final result would be W equals 19 joules.